2.5. How do you find the slope between these 2 points? Y minus y over x minus x. 1.5. So therefore, if the slope from here to here is 2.5 and the slope from here to here is 1.5, shouldn't the actual slope be somewhere in between 1.5 and 2.5? That's the intermediate value theorem. So they're saying that the slope is 2. Is that possible?
Yeah.
Yes, it's possible. So A is a possible answer. And then if you just take a look at the other one, some of them, there's no way the slope can be equal to 2, so you eliminate that. And then the next thing you gotta look at is the graph is concave what? Down or up?
Down.
Now, is this possible?
Yes.
Is it possible for this to be concave down?
Yes. It's
Why?
increasing by less and less.
Why? Okay, because look. Here, let's just plot the points. 2, 2.5. That's not 2. 2, 2.5, 3, 5, and then 4, 6.5. Now, if the slope from here to here is what? 2.5, and that's 1.5. Is it possible to be concave down? Yeah, but what if this point was like, what if this slope is 2.5, and then the next slope was 3.5 or something? Is it possible to be concave down? No. So the key to doing this problem is you gotta look at the slopes between the points. That's what you gotta do. Okay, we only got 20 minutes, less than 20 minutes left. We're in trouble.
Wait, what are we doing?
Going back to basics.
What does that mean?
I'll tell you what. Okay, one problem that I noticed we had 2 free responses. They give you a chart and they ask you all of these different questions. Some of you don't even know like what to do. We're gonna take care of that right now. Okay, so x, f of x. I'm gonna give you a chart. I'll just give you one with 4. How about 2, 3? No!
No!
1, 3, 6, 10. And then how about 7, 5, 3, 2? F is differentiable. F prime of x is less than 0. F double prime of x is, I don't know, just say greater than 0, even though it might not be true. Okay, now let me ask you some questions.
I'm probably gonna lose the paper, to be honest.
Huh?
Nothing.
No. Just listen, watch the video again. If you just listen and absorb it, okay, look. Estimate, I'm gonna call on people. F prime of 6.
I'm coming back.
Okay, whose turn is it?
Let's go.
Douglas.
I've never done
Estimate F prime of 6.
He knows better.
Okay, so they want you to estimate the slope when x is 6. So look, is 6 on the chart? Okay, so the rule, what's the rule? If it's on the chart, what do you do?
Look at the thingy.
You gotta use
Left
the
and right
point
hand.
that's closest to it. So which point is closest to 6, 3 or 10? No, how far is it from 3 to 6? 3. How far is it from 6 to 10? 4. You have to use the closest one. So all you have to do is find the slope between these 2 points. Okay, go. No, Goblin.
Okay, 3's on the bottom.
Nice.
No,
Okay,
no, no, I don't want the answer. I want you to write down the slope formula. Remember?
F,
No, y minus y.
yeah,
Look, y minus y.
yeah.
Yeah, so. Here, I'll do it for you. 3 minus 5 over.
6 minus.
Don't listen to him! Nobody better. You guys, if I don't call on you, I don't want to hear anything. Goblins, how do you find slope? Y minus y over x minus x. And you just leave it. You do not simplify it. You guys understand?
Yes.
Okay, when you estimate a slope, that's all they want you to do. They want you to go y minus y over x minus x, but you have to use the correct points. Okay, next one. Estimate.
What?
I just sensed something. Estimate f prime of 4.5. Now, is 4.5 on the chart?
Negative.
So wait. Okay, so Chung, what do I do? Yeah, you use the 2 points that immediately surround it, so that would be these 2. Oh, so it would be the same thing? Yeah. Okay, there you go. So it'll be 3 minus 5 over 6 minus, and please do not go, who are the columns going x minus x over y minus y last time?
Bang, bang, bang.
I've never done
That
in
is
my
so
entire life.
terrible.
Take that.
This problem is only going to be worth 1 point.
The guy who said I hate
Hey, we gotta get through this stuff. Estimate the integral from 1 to 10 of f of x
No,
dx
you did.
dx using a 3 left endpoint Riemann sums.
What?
Okay, so who's up for this one? Takata. Estimate this integral using 3 rectangle. A Riemann sum means rectangle, right? Okay, left endpoint. Go.
2 times 7
Yup.
plus 3 times 5 plus 4 times 3.
Oh.
And that gives you a grand total
No,
of.
just leave it. Just leave it.
He said 35. He said 35.
We can check the bill.
41. 41.
That's why this is 1 point. You just lost the point. When you do that. Why do you guys feel the need to compute it? Just leave it. Just leave it. Does everybody understand this? Does everybody understand this?
Yes.
Then how come we're getting all those problems wrong? Okay, B, 3 right endpoint Riemann sums. Okay, who's after Takata? Okazaki.
2 times 5, 3 times 3, 4 times 2.
See, that's how easy it is, man. C, using 3 trapezoids. Pat, 3 trapezoids. 1/2. Yes. Oh, you're gonna factor out the 1/2. Okay, it's up to you if you want. Shh.
3 times 5 plus 3. 4 times 3 plus 2.
Very good. For a grand total of
No!
Okay, now here's a question. Okay, part A. Is this an under or an overestimate? We learned. Is this one an under or overestimate?
It is
Tell me what you're looking at.
I'm looking for the concavity.
Okay, that's wrong, Rick. Okay, when you do a Riemann sum, left or right endpoint, what determines the under or overestimate?
Oh, no, increasing.
Whether the function is increasing or decreasing, so you should be looking at that.
Okay, okay.
If the first derivative is negative, that means it's decreasing. Okay, so
It is an underestimate because
well, if you use the left, okay, if you have a function that's
Says
decreasing,
FMX.
if you use the left endpoint to cap off the
I see.
rectangle, oh,
well, then it's increasing because FMX.
no, it's not increasing, the function is decreasing already, you can't change
It's
that.
overestimate.
It's an overestimate.
Because FMX is decreasing.
Thank you, that's exactly correct. Okay, what about part B, Nakama? Is it an under or an overestimate and why?
It's an underestimate because of the x is decreasing.
Very good. You guys got that? The function is decreasing. See, just draw a picture like this. If I use the right endpoint, hey, that rectangle is smaller than the actual area. And then what about part C, Ujimori? Over or underestimate? How do you tell for trapezoids? Concavity. Well, then you should be looking at that. If the second derivative is positive, that means the graph is concave up. So
It's over.
it's an overestimate. Why?
Because it's concave up.
No, you can't say it's.
Or the function.
What function? No, you have to be, what function are you talking about? Yeah, f is concave. You guys understand that? You cannot say it is concave up, or the function or the graph is concave up. You have to say f is concave up. Do you understand that? Then how come on the next test where I'm gonna test you on this, you guys are gonna write that? I know. Okay, next, we're not done yet.
We're learning.
Okay, yeah, exactly. Arakawa, compute this integral. What's the integral of f prime of x dx from 1 to 6? Compute this integral.
So
Arakawa.
you use f of 6 minus f of 1.
No grand total, just leave it. Okay, do you see what Arakawa did? Fundamental theorem of calculus part 2, or code red. It's that simple. What are you guys doing over there? I want you guys out there.
No, what?
Pay attention then.
Us?
Pay attention.
I'm writing stuff down. You just erased it, so I started writing it down.
Find the average rate of change of f from, let's just go on the interval from 3 to 10. Okay, whose turn is it? Uechi. How do you find the average rate of change? Right there.
1 over v minus a.
Okay, I'll let you continue because you could be right.
10
1 over b minus a.
times the integral of f of x from
Okay, then that's wrong already. Okay, you're thinking of average value, right? That's the average value formula. This is average rate of change. It was on a speed quiz not too long ago. What's the formula for average rate of change then? So now, substitution. Average rate of change. It's a simple formula.
F of b minus f of a over b minus a.
Thank you.
Oh,
It's
God!
f of b minus f of a all over b minus a. That is called the average rate of change.
It's brilliant.
It is not an integral. You guys get it? However, average value is an integral. Okay, and then you just read it off the chart. Can I assume you guys can read it off the chart? No, you can't. 2 minus 5 over 7.
grand total is
Okay, who's the next one? Is there a value of c somewhere between 1 and 10 such that f of c is equal to 4? Okay, whose turn is it? Among.
I'm excited.
Is there a value of c somewhere between 1 and 10 such that f of c is 4?
Allow me to check.
It's a yes or no question.
Yes.
Okay, yes, you get 1 point. Why now?
The intermediate value.
Very good.
theorem.
The intermediate value theorem.
Guarantees it.
Exactly. But you probably should say, since the function is continuous, because it has to be continuous in order for this to.
Well, if
Since-
it's differentiable.
Yeah, but if it's differentiable, it's
continuous.
continuous, right? So, since this function is continuous, the intermediate value theorem.
Wait, can you go over the difference
Elementary.
between the mean value?
Yeah, because the next question is going to be the mean value theorem. The intermediate value theorem says, look, it's like here. The y coordinate at 1 is 7, right?
Mean value.
The y coordinate at 10 is 2. To get from 7 to 2, just think about it, look. To get from 7 to 2, don't you have to hit 4 somewhere in between there? That's the intermediate value theorem. Okay, what if I said instead of 4, what if I said 0 here? Then Matsukawa.
No.
No, we don't know for sure.
Well, yeah, but it's not,
We-
because
it
it's not the
doesn't-
range.
Yeah, exactly, so
Could be anything.
there may be, but we don't know, that would be your answer. Because the intermediate value theorem won't guarantee that one, right? Because 0 is not in between 7 and 2, that's why, right?
Yeah, so we can
Just
put.
say-
There is no theorem then,
Yeah, so we don't know, the answer is we don't know.
Wait, is that everything?
Just
there?
write
You
No,
don't
because
know
we
what they're
don't
gonna
know.
ask on AP exam. Okay, quick, we got 4 minutes. Is there a value of C between, okay, let's just go 1 and 10 again, such that f prime of C is equal to -5/9. Okay, Matsukawa, you're up here. Is there a value of C? Now, what's the difference between these two? This is F. When you see F, you're thinking, okay, they're asking me about the intermediate value
Yeah, this
theorem.
is,
But now they're asking about the
mean value
derivative.
theorem.
This is the mean value
Of
theorem.
course. I just.
Okay, so yes or no? What does the mean value theorem say? If you have a differentiable function, which it is, there's at least one place in between there such that f prime of c is equal to what? F of b. This is a and b here now. F of b minus f of a all over b minus a. What is f of 10? Look at the chart. 2. What is f of 1? 7. Is that the same thing as -5/9? So the answer is yes. Why? Since this function is differentiable, the mean value theorem guarantees it. Okay. Is there a maximum value on the interval from 1 to 10? Yeah. Question
But
mark.
there is? Oh,
Okay, let me ask
yeah.
some Watase. Okay, the answer is yes. Okay, correct. Okay, now why?
Is the answer ever no for any of these?
Well, most of the time it's yes, but
So if
the
you had
important
to
part is
guess-
the reason.
If you had to guess, you guess yes.
Okay, yes, okay, but now why? This is gonna separate us between the 4 and the 5.
Sheep and the goats.
Okay, you have to refer to a theorem that's on the cheat sheet. Okay, what theorem talks about anytime you have a continuous function, there will be a maximum and there will be a minimum. It's called the extreme value theorem. The extreme value theorem guarantees it, since the function is continuous. So those are 3 theorems you gotta know. The extreme value theorem, the intermediate value theorem, and the mean value theorem. Oh boy. Okay, here we go. I'm just gonna, okay, we got 1 minute left. Let's see if we remembered anything from this. Who's next? So Kai said that, Kojima, what is the solution to this differential equation? dy dt equals 7y. Yesterday's speed quiz. Now, if you want to reinvent the wheel, you can put all the y's on the left, all the t's on the right, and go through that whole process. But this is the one that we're supposed to remember. Goblins. I'm going to keep asking till we get it. So there's no theorem. It's just that what is the solution to this differential? You got to recognize this one. Show me. Oh, y equal.
Y e to the 7t.
That's what I'm talking about. Why are you clapping for like? That's like saying, "Oh, you're reading today." Hey, yeah. You're supposed to know this.
You guys sound like soccer.
So this is the kind of stuff I want to do in the last 5-10 minutes of each class. Because, like I said, I cannot trust you to study the cheat sheet on your own. Okay, so what's Monday's quiz? No, those three quizzes on Monday. What's the regular quiz gonna be on? Come on. Area volume. We did it. Oh yeah. Before you leave, here, on your way out. Okay, look. Listen. This is 1 through 6, so this is 2 homeworks. 1, 2, and 3 for Monday. 4, 5, and 6 for the next 6. So just make sure you get one before you leave this class. There you go. Huh? Hold on. We already went over it. Just ready, Jane? Yeah, so if you have more questions on this.
What's wrong with yours?
What is that?
You're not writing notes. That's not notes.
You do that for
That's -5 off the quarter out. Yeah!
And you,
Why are the bells not working?
it's not bad, yeah.
Everybody sit down. You got one?
No, I didn't.
Josh, it's not bad, yeah.
It's good. It's just like I don't know why you're laughing so much.
No, wait, Mr. Park, I honestly learned a lot this class.
Yeah, I know. That's why we did it.
That was good.
We have to do more of this.
Like, some of it is slowly coming back as well. Like, you're, by learning some of the stuff, it's like dislodging the other memory.